Good evening, friends. This is Ronald. I'll be taking you through derivatives. Last time we had live sessions, and I promised to record because most of us missed out due to network issues. So, after getting this recording, you prepare a few questions. Actually, I'll go through the same tomorrow in the morning for those who will be able to log in. We're going to look at derivatives. Okay? Yeah. Last time I defined this. I'll be a bit faster for the first part of this since I went through it last time. Okay. Yeah. So when you talk about derivatives, yeah, we are talking about that measurement of the sensitivity to change, yeah, of the function value of one variable with respect to change in another variable. So we are looking for the average rate of change in the value of a variable with respect to another variable. So there's a 2 there. Okay? There's a 2 there. Okay? So I said a variable is something which can change. Yeah, for instance, age is a variable, income is age, for it can take on different values. And it, it can vary over time, and it varies even between elements or individuals. Okay? Yeah, so if we are looking at the average rate of change, let's say, of income in respect to a change maybe in someone's education, yeah, we can do that using derivation or derivatives. So in this lecture, we're going to look at basically the rules of derivatives, those guiding rules, what guides us when we are looking at derivatives. I know most of us have heard about derivatives. You know, when you talk about dy dx, unless you've heard of dy dx. Okay, those are the things we are going to look at. Okay, so we are going to look at the rules of derivatives. There are some guiding rules we follow when you're talking about derivatives. Like any science, we be with the rules. Okay, reduce please. Like any science, we be with rules. So we're going to look at those rules which guide us when we are dealing with derivatives. The first rule we have is the constant rule. We will talk about these rules in details. Actually, for the constant rule, I didn't record details of it, but a constant rule is very simple. Okay, the derivative of a constant is 0. The derivative of a constant is 0. Whenever you find a derivative, a constant, its derivative will be 0. And I said a constant will be a number, an independent number. Yeah. For instance, if you're looking at the y dx, or the change in y in respect to change in x, any number without an x will be a constant. Yeah, without an x or another element. Okay, so those are constants. Be it 100, a million, a billion, that's a constant, provided it doesn't have let's say x or a y. Okay, its derivative will always be 0. It will be 0. The power rule, we are going to talk about the power rule in more details. I talked more about the constant rule because I don't have a session on it. We have the quotient rule, product rule, and then the chain rule. We are going to look at all these rules in this lecture. These are the guiding rules. These are the rules which guides us when you're talking about derivatives, and I'll look at each of them in details. Okay, I'll look at each of them in details. Okay, the power rule. The power rule. Okay, the derivative of x to the power n is found by you multiply by the power or the exponent, and then you subtract 1 from the original exponent or power. That's the power rule. Okay, you multiply by the exponent or the power, and then you subtract 1 from the original exponent. Like you can see the one I put in yellow. Yeah, x is to the power n. Okay, so we multiply by the n. That's why you're seeing n. This dot means multiplication. N times x to the power n minus 1. We said we subtract 1 from the original exponent. So that's the rule. Yeah, so whenever you find a power and you want to get its derivative, that rule will always take precedence. Okay, you multiply by the power and then you subtract 1 from the power. Don't say me, I hate 1s. Me, I will be subtracting with a 4. Yeah, it has to be a 1. Okay, then we have an example. If function x is x to the power 3, then find the derivative of x, or find y dx. Okay, x to the power 3. Yeah, so the exponent or the power in this case is 3, and we said you multiply by the power or the exponent, which is 3, and then you subtract 1 from the original exponent. So we are going to multiply by 3. That's why you are seeing the 3 in yellow. It means we are multiplying by the 3, okay, and then we are subtracting 1 from the 3. Are we together? So our answer will be 3 to the power 3x squared as the derivative of x cubed. You multiply by the 3 and then you subtract 1 from the power, which is 3, and then the answer will be 3x squared. 3x squared. Okay. Example 2. If x is if the function of x is 2x to the power 1, of course the ideal would be having just 2x, but I just put that 1 to remind us that whenever you see, let's say 2x, that x has a power 1. Okay, has a power 1, and the rule is the same. You multiply by the power and you subtract 1 from the power. The power is 1, so you're going to multiply by 1. That's why you're seeing 1 times 2. This dot, like I said, is a times x to the power 1 minus 1. Are we together? So don't fear and you say now if it's 1, how can I subtract 1 from 1? It's the rule. Any number you'll be having up there, be it a negative, yeah, you have to subtract 1 from it. Alright, so after doing so, we remain with the 2x to the power 0. Recall x was the power 1 and we subtracted 1 from the 1. 1 minus 1 is 0. So we remain with the 2x to the power 0. Now someone may, and our answer is 2. You may wonder, how come? Where has the x to the power 0 gone? It's very simple. Yeah, just remind us. Yeah, if you recall our primary math, yeah, they taught us that any number to the power 0 is 1. Okay, so x to the power 0 is 1. Any number to the power 0 is 1. So please always recall that any number to the power 0 is 1. Meaning if I have 2x to the power 2x, my answer will be 2. Yeah, so the other thing what you need to know, of course, not for you to cram that, whenever you're having a number or our variable without a power, yeah, okay, yeah, the answer will be the base or the multiplying coefficient. The answer will be the multiplying coefficient for that case. So if it's 2x, the answer will always be 2. Yeah, 30x, the answer will be 30. 40x, the answer will be 40. Yeah, but of course this is how we get it. Yeah, if I subtract 1 from 1, I remain with 0, and then now the power 0 is 1. You can try that number, 4x to the power 5. I know some friends, some people tried it out and shared with me. You can as well try it out, assuming, or in case you're watching this for the very first time, you are attending this for the very first time, you can try out that number. Recall, we said you multiply by the power and you subtract 1 from the power. Okay, so let's move on. Yeah, that's the answer. I got it. Now we have the product rule. Yeah, so to find the derivative of a problem where we need to multiply for example, x cubed times x squared plus 2, then we use the product rule, or y is equivalent to u times v. We are assuming the first function is u and then the second function is v. So we use this when we are multiplying functions. You're having the first function x to the power 3 multiplying through the second function, which is x squared plus 2. Yeah, so the power rule, the product rule is y. Okay, we are going to have that number. Yeah, so you can assume the first function to be u and then the second function to be v. Yeah, so the rule is you get the first function times the derivative of the second function plus the second function times the derivative of the first function, or u dv dx plus v du dx. Let me repeat. We are presented with these two functions which are multiplying through each other. One is x cubed, which is multiplying into x squared plus 2. And we want to get the derivative, or want to differentiate y in respect to x. So we say the rule is very simple. You're going to get the first function, which we are calling the u, times the derivative of the second function, that we are calling v, plus the second function, then we are calling v, times the derivative of the first function. Yeah, that's the rule. That's the power. That's the product rule. That's the product rule. And what you need to know in situations whereby you find these rules mixed in a number, they will all apply. Like for in this case, we will use the power rule and the constant rule somewhere. Alright. So after knowing that you will need the derivative of u and the derivative of v, then it's good you first get those derivatives. Okay. So let u be x cubed and let v be x squared plus 2. So we will need, based on our formula, we will need to get the derivative of u. Yeah, all together. So like I said, derivative can be symbolized by the element with a with this hyphen. I think it's a hyphen. Okay, or the y dx. It means derivatives. Okay. So the derivative of x cubed, if you recall our power rule, will be 3 times x cubed minus 1. So our answer will be 3x squared. Yeah. And then we need to get also the derivative of v. Yeah, we need to also get the derivative of v. Okay. The derivative of v is x squared plus 2. Yeah, this 2 is a constant, meaning it's already a 0. Whenever you see a constant, be it a million constant or anything, in your mind, just know that's a 0. Okay, so this is a 0, and then I have x squared. So x squared is the same as 2 times x, and then the power 2 minus 1, which is 2x. Okay, you should be knowing that the derivative of the constant is a 0. Okay, recall, this is our formula. So now we are going to just substitute whatever we've calculated into the formula. Yeah, Sharon, get me some drinking water. Hurry.
Okay.
Yeah, I'm getting here some water. So if you also have water, you drink. Okay. Alright, so we are now going to substitute what we've calculated into our formula. Yeah, recall, we needed the derivative of u, which we've gotten. We needed we needed the derivative of v, which we've also gotten. So we're just going to substitute. Okay, so our u was x cubed into the derivative of v, or the v dx, which is 2x, like you'll see. Yeah, plus our v, which was x squared plus 2, thank you, into the derivative of u, which is 3x squared, which is 3x squared. Alright, okay, so we're still talking about our substitutions. We substitute everything into our formula. Yeah, we've substituted the u, which is x cubed, yeah, into the derivative we got, the derivative of v, plus our v, x squared plus 2, times the derivative of u. Okay, so this is our answer. You can break it down further, or you can choose to keep it at this. Yeah, so if I'm to break this further, if I'm to break down this further, I would be having, this would be 2x to the power 4 plus 3x to the power 4 plus 6x squared. That would be the answer, but you can leave it at that. Please try this. If you feel like sharing with me your answer, please do try this out. Now let's move to our quotient rule, or the division rule. Why suffer? Division rule. Division rule. Division rule. Okay. So given two differentiable functions, the quotient rule can be used to determine the derivative of the ratio of the two functions. Yeah, so if you're having two differentiable functions, yeah, and they're dividing through each other, then we can use the quotient rule to get the derivative of those functions. Yeah, so here we're having function x is dividing through, or is dividing by the function g. Yeah, function g. Okay, function g. Yeah, so the quotient rule would be given as that. Yeah, so to get this, the simplest formula, I prefer the one I put in yellow. Yeah, like since I earlier used u and v, yeah, we can as well use them here. So the formula is v du dx. Okay, v du dx minus u dv dx over b squared. Let's simplify it. Yeah, we are saying we can assume that our numerator is u and our denominator is v. Yeah, so after assuming that our numerator is u, okay, the upper one is u and then the downer one is v. Okay, so then we now look back to our formula. This formula is the same as this, but let's use the one in yellow. Okay, the upper part is u and the downer part is v. Like earlier we said, the first part is u, the second one is v. So the rule is saying that we are going to get the second function, or the denominator, okay, times the derivative of the numerator, the one which is up, minus the numerator times the derivative of the denominator divided by the denominator squared. Now I may sound like speaking in tongues, but I repeat. We say that we are assuming the first function, or the numerator, to be u and the denominator to be v. So we are saying to get the derivative of that, we will get the numerator times the derivative, we will get the denominator, that which is down, times the derivative of the numerator minus the numerator, which is the upper one, times the derivative of the denominator, which is down one, divided by the denominator squared. In simple terms, yeah, the down one will multiply by the derivative of the upper one, and then you subtract the upper one multiplying by the derivative of the downer one, then divided by the downer one squared. So this is our formula: v dx minus u dv dx divided by v squared. So we're having an example here. Yeah, we are having an example to differentiate y, which is equivalent to x squared minus 3x minus 1. Like I told you, the first thing is letting, yeah, simplifying this by calling the numerator something and the denominator something. Yeah, so in this case I've used u and v. Yeah, u and v. So we let the upper part be u. Like you can see here, let u be x squared divided by, okay, so we let the denominator to be v. All together. So our numerator is u and our denominator is v. And recall, we should do all this while having our formula in mind. In our formula, we need to get the derivative of the numerator, and we also need to get the derivative of the denominator. That's why at this point, after letting u be the numerator and v be the denominator, you get the derivatives. at this point. Okay, our numerator is x squared, and the derivative is very simple. You multiply by the power and subtract 1 from the power, so it's 2x. That's the answer. Okay, and then the derivative of the denominator, the denominator is 3x minus 1. 1 is a constant. 3x, like I said, if I'm faced with 3x, I will automatically know that the answer is 3. Okay, if I have 3x, the derivative will automatically be 3. How? Yeah, 3x, x is to the power 1. Yeah, so I get 1 minus 1, I remain with 0. Okay, and recall I had earlier multiplied by 1. Okay, let's do it. Let's just do it here. Let's just remind ourselves. Let's just do it, and we remind ourselves. Let's just remind ourselves. Okay, let's just have a reminder. It's not a product rule, and just reminder. Okay, alright, let me show you how we got it. You may be wondering. Okay, so this is how we got the derivative. And let me use a different color. Okay, it's 3x minus 1. Like I told you earlier, 1 is automatically 1 is automatically a 0. 1 is automatically a 0. Yeah, 1 is automatically a 0. 1 is automatically 0. For the derivative of a constant is always 0. So then we have 3x. We have 3x to the power 1. Yeah, 3x. There's a power, a silent power here, which you may never be given, but you should know if I'm having 3x, is the that x is the power 1. So we said we multiply by the power. So if you are to multiply by the power, then this will be 1 times 3x to the power 1 minus 1, according to the rule. Yeah, you subtract, you multiply by the power and subtract 1 from the power. So here our answer will be, let me put this in a different color. Let me put it in yellow. Okay, I'm just reminding ourselves. Alright, then we have, so this will be 3x. 1 times 3 is 3x to the power 0. Yeah, 3x to the power 0. Let me use a simple power, that one, to the power 0. Okay, and any number to the power 0 is 1. Okay, number to the power 0 is 1. So that means this is the same as having 3 times 1. Yeah, or let me use a star. 3 times 1, which is equivalent to 3. That's how we got the 3. Yeah, that's how we got the 3. And then to get this 2x, we were getting the derivative of u. Yeah, recall we said we're getting the derivative of u. Recall we said you multiply by the power is 2. So we have 2 times, yeah, x to the power 2 minus 1. Okay, to the power 2 minus 1. 2 minus 1. This means power. I didn't want to go into the equations and so on. Okay, so this gives us 2x to the power 1. 2x to the power 1. 2x to the power 1, which is the same as 2x. That's how we got the 2x. So you shouldn't be confused as to how we got this. We just used our earlier function, our earlier rules. That's how we got that. Okay, so after getting this, we've gotten our derivative of u as 2x and the derivative of v as 3. Yeah, the formula excuse me, according to the formula we are going to get the v, which is the denominator, minus the derivative of the numerator, minus the numerator times the derivative of the denominator over the denominator squared. Okay, but we should recall we've already calculated for the derivative of x. Yeah, recall derivative of u, the derivative of u, yeah, which is equivalent to this, which is the same as du dx, is equivalent. Yeah, then we are just trying to bring the answer we got. Our answer was 2x. Yeah, it's 2x. 2x. Yeah, that's our derivative of u. Okay, 2x. 2x. Try and just put it in different color. 2x. Okay, 2x, and then our v, that, or the derivative of v was 3. That was 3. Yeah, remember, I'm putting this because we will need this to substitute into our functions or into our formula. Yeah, okay, and then the v, yeah, this we are just recording the answers we have. Okay, so at least we need the v and the u, we know the v. Okay, let me also put it again. I should have put the v and the u first. Okay. Let me just get this. Okay. Oh. All right, so now on my right I'm having everything we need. Okay, we have our u, okay, so from this we got that. Okay, and from this we got that. All right, so we are now just substituting this into our formula. Yeah, the formula said we need v du dx, so our v is here, 3x minus 1, so we have our 3x minus 1 here, times du dx, our du dx is 2x, so we put our 2x here, and then minus u, our u is x squared, that's why you're seeing the x squared here, times dv dx, our dv dx is 3, divided by the v squared, our v is 3x minus 1, so we are dividing by the v squared, or 3x minus 1 squared. Okay, so we can now this further. Yeah, we know this is 2x into 3x minus 1. Yeah, I can have this multiplying into each and every element inside here. So I'm having 2x times 3x, it will be 6x squared. Yeah, 6x squared, and then if I have 2x times 1, negative 1, I will get my negative 2x. Then minus 3 into x squared, This is the same as 3x squared. You can leave the denominator. You may not need to, to struggle a lot with breaking it down. Okay, so 6x squared minus 2x minus 3x can be broken down, yeah, by having this 3x squared separated from the 6x squared, because they're the same. X squared, x squared. So I'm just going to do this 3 from the 6. So we'll remain with 3x squared minus 2x divided by 3x minus 1 squared. That's our quotient rule. That's our quotient. The key is knowing the formula and knowing what to put in the formula. Because if you know the formula, you will have your side work. Yeah, like you have a v, the v is there. You need a u, the u is there. You need the derivative of u, you differentiate the u and you get the answer. Like in this case, we have the 2x. You need the derivative of v, you differentiate the v and you get the derivative of v, which is 3 in this case. After getting that, it becomes too easy for you. You can just substitute into that. Please try out those 2 examples. Like I've said earlier, you can share with me your answers if you feel like. Please try out those 2 examples. Thank you very much for now. I'll be sending another video on chain rule. Actually, I'm going to do it now. Yeah, but let me stop, or let me end this at that. Okay, our next video will be on chain rule. Thank you very much.